Okay, guys, how's everybody doing today? All right. I'm sorry I'm not swag enough for you, but I'm just a math teacher. You know, that's the way it is. Boo. All right, not swag enough. All right. Well, I'm definitely the swaggest calculus teacher ever. See, I got a little buzz right there. That's right there. All right. So we're going to do on the practice exam, we're going to do put your name at the top, and you're going to take a picture of this page when you're done and email it to Mr. Werthinator. Practice exam. And it's, yeah, you know what that is, right?
Yeah.
It's April Fool's Day. I was going to do this problem. Now I'm not. Ha ha, April Fool's. Okay. All right, great. Okay, so let's do, they're asking us on, you can look at the answers. Sometimes that's a really good test taking strategy. You look at a problem and you stare at it and you're like, I have no idea what that is. Then read all the answers and then you're like, oh, that's what they want, right? So I look at this piecewise function, I see has a parabola and a straight line and it breaks at x equals 5, right? And it says, let f be the function defined above, which of the following statements about f is true? And I'm like, well, what do I do? Because it doesn't really tell you, give you any directions or tell you what to do. But if you read the answers, then you're realizing what they're looking for. So they're asking you if it's continuous and differentiable, or not differentiable, or not continuous, or neither. So basically what I have to find out is this thing continuous and differentiable? Now you could go through all the trouble of making a graph and everything, but you don't need to. Because the first part of this function, negative x squared plus 3, that's a parabola. Parabolas are continuous everywhere, right? All polynomials are continuous everywhere. They're smooth, connected curves all the way across like that. And so is the next one, minus 10x plus 28 is a straight line, which is a 1-degree polynomial, right? X to the 1 power. And x squared is a 2nd-degree polynomial. It's called a quadratic or a parabola. Okay, so you have two polynomials that are connected together, and they're asking you if that's continuous. So to find out if it's continuous, we got to find out if those two pieces meet up at 5. So basically what they're asking us for is the limit as x approaches 5 of f of x. They're asking you for this. If this limit exists, then it meets up. Okay? So that's what we're going to determine. To find out if a limit exists, remember what I told you a long time ago, it has to meet from the left and right at the same point. So we have to check the left limit and the right limit. So the left limit as x approaches 5 from the low side, from the minus side, from below, is for all the x's less than 5 is minus x squared plus 3. So when we check the left limit, we're talking about the values to the left of 5, which is going to be the negative x squared plus 3 part. And it's just a parabola, a polynomial, so you could just plug it in. So negative 25 plus 3 equals negative 22. Okay, that's the left limit. Then we're going to check the right limit. The limit as x approaches 5 from the right side, from the plus high side. And for those x's, that's going to be negative 10x plus 28 on the function. And since it's a straight line, which is continuous everywhere, you can just plug in the 5. So you get negative 50 plus 28 equals negative 22. So does the limit exist?
Yes, sir.
And it equals what? Exactly, negative 22. All right. So if it exists from the left and it exists from the right, and the left limit and the right limit both equal the same value, then the limit exists and it equals negative 22 for the whole function at x equals 5. Furthermore, since all we had to do to find the limit was replace the number in there and get a value, these are also the values of those pieces, and the limit exists equals negative 22, and the value of the function equals negative 22. So if basically if f of 5 is equal to the limit as x approaches 5 from the left of f is equal to the limit as x approaches 5 from the right, then the function is continuous. Then the function is continuous. So the concept here is that for something to be continuous, the left limit, the right limit, and the value of the function all have to match. The value is the same, the limit is the same, the limit is the same. The limit, the line, the curve meets up at this point from the left, it meets up from the right, and the value of the function exists and equals that same point, then it's connected. You can draw it without lifting the pen. That means it's continuous. If you can draw it without picking up the pen, then it's continuous. There's no holes in it. All right, then the function is continuous at 5, which is true, because f of 5 equals negative 22, and the limit as x approaches 5 of f of x equals negative 22. They're both true and they're both equal. Okay, so we are continuous is true. So therefore, f is continuous at 5. We're all set with that. Now the other part was differentiable. Okay, we know it's continuous, but continuous function may not be differentiable. For example, this right here, it connects right there. You see what I'm saying? But is that differentiable?
Maybe.
It may be, but look, it's not. I'm showing you why. Because it reaches a sharp point right there. So the derivative on this side and the derivative of that side don't match up. So this has a positive derivative and a negative derivative, and they don't match. So the derivative at that point is undefined. It's called a critical point, and the derivative doesn't exist there because the left and right derivatives don't match. It's similar to limits. For the limit to exist, it has to meet up. So the limit does exist for this, but it's not differentiable because the slope on the left and the slope on the right don't match. So to be differentiable, it has to be continuous and smooth so that the derivatives match up when they cross over. See, the derivatives are smooth. The derivatives have to match. Okay, so this function is continuous but has no derivative. So how do we know that this is going to be continuous? If for this function, if the slope on the left side and the slope on the right side match up, then it's differentiable, because we already know the limit exists and they meet up and it's continuous. But if the slope meets up on the left and the slope meets up on the right, then it's differentiable. Okay, so all right, so to be differentiable, at x equals 5, then f prime of 5 from the left side has to equal f prime of 5 from the right side. Both of those derivatives have to match up. Okay, so here's how we do that. We can do it by the difference quotient for limits, which is a little more complicated, but this is a really easy function. It's just polynomials. F of x equals negative x squared plus 3 on the left side for x is less than or equal to 5. And f of x equals negative 10x plus 28 for x is on the right side. Right? So f prime is very simple. You just take the derivative. On the left side, what's the derivative of minus x squared plus 3?
Negative 2x.
Exactly. So it's going to be the derivative, the slope of this is going to be negative 2x on the left. And on the right, negative.
Oh, sorry. It would just be,
You got it, Paul? What about the x?
it goes away.
Right? The slope of this line is negative 10. It's a line, mx plus b. You understand? This is a straight line, negative 10x plus 28, mx plus b, the slope is negative 10. When you take the derivative of a one degree polynomial, the x goes away. Okay? And this is going to be on the right. Now you tell me, do these derivatives match up at 5?
No.
What's 2 times 5?
Oh, never mind. Well, yeah, no, it won't.
It does. At 5, the derivatives match. So f prime of 5 is equal to 5 from the left side is 5, which equals f prime, sorry, 10. It equals negative 10. It equals f prime from the right side. See? The left derivative at 5 is going to be negative 10. And the right derivative is negative 10. It's a straight line. The slope is always negative 10. On the left side, that curves over and matches negative 10 right at 5. And if I put those graphs on Desmos.com for you, you would see it. You can do it yourself on your Chromebook. You can see at when x is 5 that those things meet up at the same steepness, the same slope. All right, so we figured out it's continuous and differentiable.
So the answer is A.
Yep, so A is the answer on the multiple choice, and I'm pretty sure that's correct. Okay, any questions on how I did that?
Nope.
All right, continuous and differentiable. All right, fully explained.